Hello and welcome to a short introduction of SBeXpress, SBeXpress, when using it to design BAMTEC carpets. Basically, you can say about SBeXpress that it's a freely customizable, highly customizable tool with which, using AutoCAD or BricsCAD, you can draw BAMTEC plans, but not only BAMTEC plans, but also classical reinforcement plans. The concept of SBeXpress foresees that basically you draw classical reinforcement in bar steel in order to designate areas subsequently that are supposed to become BAMTEC elements. So in terms of its approach, it's slightly different from other tools that you find on the market. We first determine our reinforcement and then punch the carpets out of the already laid reinforcement, so to speak. That means the program recognizes within the geometry of the carpet which bars should be contained therein. And this I will show you in a video. As usual, we start with the formwork contour. We start with a slab or a ceiling, for instance, that needs to be reinforced. Whether it is a PDF underlay that the customer has made available or a DXF or a DWG, doesn't matter. It works in all these ways. There are also interesting tools here, in particular if you want to rework already existing reinforcement plans. Here we've drawn a simple structure, and for that we determine a formwork contour. In this case we're working with a ceiling slab or floor slab. We can position it, we can determine the basic parameters: strength, concrete coverage, and which angle the reinforcement is supposed to be laid, the basic reinforcement for the individual layers, or via the comfort function, the same reinforcement cross sections for all 4 layers. That would be command there in the middle, or individually. And then we've got a simple command. Via the layer control, we can determine for which layer we want to generate the reinforcement, and then we generate upon one click the basic reinforcement according to what we determined earlier on. That means now we've got straight bars in our reinforcement layer, in the cross section and in the distance determined. Variable length have automatically been chosen as well. Once again, we check how the reinforcement is laid on the screen, and we can configure everything again. Every layer in reinforcement can be shown as individual layer. That is also good for the blueprints afterwards, for manufacturing the blueprints, and then we can get suggestions for the manufacturing of carpets. These are the basic settings that we use. That means we want to have a bar length of 11 meters, a roll-out length of 15 to 20 meters. That always depends on how many bars we want to have per carpet, and under the parameters chosen we've got a subdivision which optically looks nice but doesn't do justice to what we want. There are still a bunch of carpets that are too short here, as you can see. So what do? In the project settings we can change the distances. We set the bar length to 12 meters and say the rollout length should be 14 or 15 meters actually in that case. And under these parameters, we're going to get a new suggestion in the program. The old suggestion is deleted, and here we go. This looks quite nice. We have the joints where we want them, and we can manually shift them. The joints and the cuts. A joint is where bars meet or are parallel next to one another. Cuts or intersections are lines along which a carpet is rolled out. So we've already got a couple of elements here. The carpets and the joint areas we don't need. The dotted lines, by the way, are the preset overlap length, which are automatically chosen depending on the standard. There are also gripping points that help us if we want to change carpets subsequently to see if we do justice to the required overlap length. Also, these parameters can be changed, can be freely set. We can click through different views. This is a test overview in which the bars are colored depending on their diameter so that the testing engineer can recognize during the test whether this does justice to the settings. This is also going to be interesting if you have additional reinforcements in the individual elements that you can test at a glance. Then now we're setting stages for the different areas. That means the view of our plan or the rendering of our plan can also display the sequence of operations or the sequence of work that is interesting for the construction site. Frequently we can change the numbering of elements and thus respectively on the plan the overview changes. The tag files are newly written when you put the carpets together anew. So that was the first layer. Very briefly, now we go into the second layer where we have different bar diameters. We've got 12mm bars in the second layer. You can see that immediately. You've got a different color of the bars. The overlap and the joint areas can be colored as well for easier testing, easier review. Once again, the sequence of operations is detailed. The positioning stages, the positioning groups, whatever you want to call that, for such a small slab, that is only an example for you to see. For larger projects, it is interesting to see where do you start, where is the overlap. When concreting using the pilgering method, thus, you can clearly decide where to start with the laying. What about the elements? How are they supposed to be loaded? And so on and so forth. The position designations you can see in the plan are freely chosen by us. We've decided to use the layer and the number of the carpet as well as the basic reinforcement for easier testing with the structural engineer, and thus also the resulting cross sections. Now we've got a simple command to add additional reinforcements. The most frequently used forms and variations are already here. Depending on the active layer and layer control, the bars are placed in the right direction. The whole thing, once again, the operator made a mistake here. Positionings can be designated immediately. Here the installation ladder is defined over a fixed length. You can show it via cursor or you can enter it as a length that can also be changed via the AutoCAD control. Bar length can easily be changed. It's very comfy, really, applying changes subsequently in this program. Very easy. The additional reinforcement is there. We've got the individual commands up here. Whole areas can be converted via 2 points. The installation can be defined. You can take over individual installations that you've drawn earlier on. You don't have to generate them via these commands. But when you're drawing the conventional reinforcement, you can already consider the additional reinforcement. We think it's easier to do the carpets first and then to see where are the joints, where do we want to place the additional reinforcement, which additional reinforcement is integrated in the carpet, which remain manual. They could be captured as well and could be applied to another layer, not on a BAMTEC layer, but on a manual layer. And then they would be shown in a steel list as additional manual reinforcement, if you want to do that. Here, once again, a short excursion through the views that are possible. Simple to switch from one view to the next. This is a rollout plan. Now you can only see the carpets with their installation points, the additional reinforcements, easier to dimension, which is also important for the structural engineer, obviously. He wants to see the individual bars, whereas for the users on the construction site, something else might be important. Here we can see a good function of intelligent dimensioning. While two cross sections, the dimensioning line can be defined and automatically the respective length can be seen. We also have the possibility to copy layers. Thus, the basic reinforcement and the carpet geometry is taken over. Additional reinforcements are not copied. It could be done manually if you need it in the other layer as well, but normally it's enough to copy the basic reinforcement or the geometries, because the basic reinforcement is a different one anyway. This is all rather convenient. The carpet geometry copied, the basic reinforcement copied. Then you can also change the basic reinforcement with 2 simple clicks, but you can retain the carpets as they have already been put in. Now we shift the joints a little bit here. If we work in stages, really we need the overlap, the respective overlap, in order to guarantee the rollout capacities of the next carpet. The dotted lines help us again, that we talked about earlier on when defining the overlap length. I believe you can nicely see the convenient functions that SBeXpress offers here. Whoever worked with Sophistics and iPlan knows how difficult it can be if you have to change carpets subsequently or generally when working in the overlap or joint areas of carpets. In SBeXpress, at any time you can change things, shift things without starting from scratch. The basic functions, the basic characteristics are retained because the concept foresees that generally you only draw bars, and over that you design what is supposed to be punched out, what is supposed to be integrated in a carpet. It's almost like baking cookies on Christmas. Yeah, once again, an overview. We've colored the layers, the additional reinforcement is integrated. We can see the individual carpets, and that, in short, is a lot of the functionality offered in SBeXpress. There are an endless number of adjusting the program to your own needs. That starts with the way the installation lines are displayed, the bars, the layouts can be freely chosen, the dimensions can freely be chosen. We've got a plan layout where all 4 layers fit on an A0 sheet. This would be the setting for a test or review plan, where the testing structural engineer can see at a glance which cross sections are there, what kind of bars are where. We've got intelligent text positioning, which considers the respective layer, the respective dimension, and shows them for the active view. This is the first layer at the bottom in a dimensioning of 1 to 100. That's right, it is the first layer. And in the next view, due to the positioning of the bars, the text positioning changes, so it's intelligent text fields. They can be used parameter controlled in many different variations. The plan heads are parameter based. Every steel table can be filtered for layers. The steel tables can be deducted from one another. I can only show which steel positions are already integrated in BAMTEC. I could filter for classical reinforcement that has to be added manually. The possibilities, the settings for the views are basically unlimited, which makes it difficult at the beginning because you might be overwhelmed by the number of options. However, once you've set up your basic pattern, it makes sure that within the shortest period of time you can adjust a host of things and show them according to your own requirements. It's a little bit like cooking. Not everybody does everything in the same way. Certain basics should be the same. The symbols, for instance, and the BAMTEC logos and everything that belongs to that, installation hints, things that are given by the BAM AG as corporate identity are taken over. Nevertheless, every company, every user can adjust the program for themselves and by themselves and adjust the functionalities to their requirements. It's a lot of input, I realize, for a couple of minutes, but it is only the tip of the iceberg. SBeXpress can do much more. We will make other videos available, for instance, for the replanning of reinforcement plans that are available as PDFs, or how you deal with IFC files, BIM-based plans, that is, or also about how you can plan via required and existing cross-sections. Here, company Müller, Thomas in that case, has done a lot of work and implemented lots of functions that we keep expanding. So thank you for your kind attention and have fun using this.